Bismillah ar-Rahman ar-Rahim. Assalatu wassalamu ala Rasulillah. So today we are going to start vectors. Okay. So this is also an introductory lecture. Yeah. And why we are covering vectors? Because in this course, later we need to use vectors a lot, especially in three dimension for system. There we are going to use vectors extensively. So although you have studied this topic in your mathematics at high school level or uh, at somewhere in the engineering level, but because we need this in this course, so I am revising that much of the vector which we require in this course. Okay, so more than that we don't need. What we are going to cover in this lecture, that much only we need for this course. Okay, so you take this lecture seriously because if you are lacking in the basics of the vectors, you will face a lot of difficulty, especially when you will be analyzing forces in 3D. So these are the topics that we are going to cover, inshallah, in this lecture. Now I come to the objectives of this lecture. So in this lecture, we will first define what are scalar and vector quantities. Okay? This is the first thing. And then we will provide you an overview of most common vector operations. Like you have scalar operations, addition, multiplication, subtraction, division. Similarly, we have also vector operations, addition of vectors, subtraction of vectors, multiplication of vectors, etc. So how to do those operations in vectors, that also, inshallah, I will explain. Now quantities, Shay. Quantities, as you know, are two types. First types are called scalar quantities and other are called vector quantities. So who will tell me what are scalar quantities?
It's quantities with the only magnitude, no direction.
Yes, yes, very right. Yes, Mr. Faisal, you also want to say?
Yes, scales with without direction, vector, scalar magnitude, and without direction, vector. That's the same scalar, but with the direction.
Yes, yes. Actually, very correct, both of you. The scalar quantities are those quantities which can be fully defined, eh, with the help of only magnitude. They don't require at all the direction for their specification. For example, if you go to a baqala and you can ask there, I need 1 liter of halib, 1 liter laban, 2 kilogram of rice, 1 kilogram of potatoes, okay, through 2 kilogram of basal. So here, when you are saying the quantities like for halib, for laban, for basal, for batatas, you don't require to specify any direction. So such quantities we call as scalar quantities that they don't need for their specification the direction. Only telling the magnitude is enough uh, for conveying the meaning to the people. In engineering, there are certain quantities which are of this type, like speed, mass, time, volume, density, and energy, etc. Okay, So like when you are like this is the picture of a speedometer. All right. So this speedometer will tell only that how fast your car is moving. So if it is at 120, it will give you 120 kilometers per hour. So by this speedometer, you can know what is the speed of your car. And even if you can put your car on cruise and then you can move straight and then leftward, rightward, and you will find that the needle in the speedometer, it remains at one place. It means by changing the direction, your speed is not changing because you have put it on cruise. And this is because speed is a scalar quantity. Had it been a vector quantity, then with the change in direction, the speed would have been changed. But this does not happen. You can see you have put your car on cruise and you're going in different directions, but you find your speedometer remains at the same place because speedometer measures speed, not the velocity, which is the vector quantity. And because of that, your your speedometer does not change. Same thing about the mass, same thing time, yeah, volume, etc. And another type of quantities, as you were saying, is the vector quantity. And when we come to the vector quantities, these quantities can only be fully defined when you have specified both magnitude as well as the direction. If any of the two things changes, your quantity will change. Hmm. So both are important for their complete information. Yeah. If any of the two things is missing, then the information which you are conveying, that it will be incomplete. Okay. I'll give an example of a door. You might have seen in many glass doors, they write on the door like pull or push. Okay. So this pull or push, it is telling what? Why pull and push?
Force.
Direction.
Well, yeah, direction. So actually it is giving you, it is guiding you about the direction, that in which direction you should apply force in order to open the door. So this is telling you the direction, okay? And now another, what about the magnitude? How will you know how much magnitude you have to apply? Because they don't write on that. They don't write 10 Newton, 20 Newton, 100 Newton, nothing. Yeah. So magnitude, how do you estimate? How much force you have to apply? Anyone can answer this? How do you know what magnitude you have to apply?
The door weight, at least.
But you don't know the door weight even. Hmm.
You just keep pushing until it moves.
Okay. Yeah, actually, the magnitude is calculated by our brain by seeing the door. Yeah. If the door looks quite heavy, brain will give the signal to the hand that apply a large force, and if it gives the signal, that apply the little force. Actually, we many times thinks that our brain does not cannot do the precise calculation, but sometimes you see, uh, our brain is such a machine Allah subhanahu wa ta'ala has made that it does very precise calculation sometimes. Hmm. Like when you want to cross a road, hmm, and you are seeing the continuously the vehicles are keep coming. Hmm. So this is the brain which estimates the two timings. First, it estimates with your own normal speed, or if you are planning to go by running, whatever it is, how much time you will take to cross the road and how much time that vehicle will take to reach to the place where you are. So when it finds that with your running speed or with your normal speed, you can cross the road in lesser time than the speed which it estimates, and then it calculates how much time it is going to take, eh, is less than that. Then it says eh, instruction to the leg that move, and then we move. Okay, so magnitude is calculated by our brain. Hmm. And and so many things, like even like when you start your car, eh, you put the key of your car into the place which is made for ignition, start of ignition. So most of you know that r- rarely any one of you go and put his head and see where the hole is, and then you insert that one. Rarely, because just one, two, three times you drive, you have run your car, and then you know your brain knows where it is, and just blindly you put your key, and it goes into that particular hole which is made for starting the ignition. Okay, never ever you might have experienced that it is up or it is below. It is so precisely goes into the same opening. Okay, so the magnitude is calculated by our brain. Hmm. And there is a disease that is called Graves' disease, in which the brain fails in calculating the things, how much force it has to apply. When I was a student, there was a Kenyan student who was living in the same hostel where I was. So I personally saw him having this disease. So his brain was not able to make the calculation how much force he has to apply. Hmm. So even when he has to lift a pen, he was applying the force as he has to lift a heavy suitcase. And when he has to lift a suitcase, he was applying as he has to lift the pen. Even he was not able to chew the food because the brain was not telling how much force you have to apply to chew it. Eh. So he was used to take some injection that was working about 2 hours something, and in that 2 hours he was doing these things for his needs, and this way he was continuing his life. But later he went for an operation for the same disease, and then he passed away. So it is our brain which calculates how much magnitude our hand should apply, and accordingly it gives the signal to the hand, and then hand applies the force. So magnitude is from the brain, and for direction that sticker helps that you apply forward or backward direction. Okay, so vector quantities are those quantities which can completely specified only and only when you have specified both, that is the magnitude and direction. In engineering there are so many examples of vector quantities, like weight, as we had discussed in the earlier lecture. The weight is a force by which the earth pulls everybody towards its center. So if this is the body and this is the earth, so always earth is pulling the body towards its center. So this is the direction of this force, and the magnitude of the force you can calculate, as you know that G is always constants m into G. So by this formula you can calculate the magnitude, and the direction will be toward the center of the earth. All forces, as I discussed just now, they are the vector quantities. You must have to specify the magnitude as well as the direction for their complete specification. Displacement, velocity, and acceleration, they are also the vector quantities. I will discuss this in the next slide. Moment is the effect of a force to rotate a body. If you want to rotate a body, you must have to apply a moment about certain axis. Only then you can rotate a body. Momentum, which is the mass and velocity product. Okay, this is also a vector quantity which acts in the direction of the velocity. Okay, and it depends on both mass as well as velocity. Yes, Mr. Omar.
Doctor, honestly, we all did these things in the previous semester in the physics course, so we are
Very good.
familiar with these slides,
Okay,
especially
very good.
this one.
The definitions, huh?
Yeah, yeah.
No problem. No problem. Let it go because
Yeah, Doctor,
uh,
the scalar and vector, we study it.
yeah, yeah, very good, mashallah. So I will go
See.
a bit quickly. No, no problem. Actually, because this is an introductory lecture, and uh, the operations which I will be discussing now after this unit vector, etc., that you require a lot in this course. So that's why I'm revising it. Okay, I know this you have studied. Hmm. Okay, so these are the uh, vector quantities. All right, and this is the example of a plane, aeroplane. Yeah? And in when an aeroplane flies at certain height with a constant speed, who anyone can tell me uh, how it maintains its height and how it goes with a constant velocity? Anybody has idea? For an aeroplane, when it is at a certain height, okay, it flies in the sky with constant velocity or constant speed, you can say, okay, in particular direction. Actually, your aeroplane, when it is not coming down or not going up, that means in a vertical direction, it is not having any force, or total force is zero, or it is in equilibrium. And that equilibrium is because of the weight which is acting down and the lift which is acting up. So this lift and this weight, sorry, this lift and this weight, they are balancing each other. If the weight is more than the lift, then the aeroplane will come down. And if the lift is more than the weight, then the aeroplane will go up. So at when it is at a certain height, then it is so calculated that lift and weight are equal. So the total vertical forces acting on the aircraft is zero. So it will maintain a constant height. Now about the horizontal velocity is zero. That means, as you know, F equals to mass into acceleration. Okay, mass into acceleration. That means its acceleration is zero. Okay, that's why in a particular, if it is moving in a straight line and with constant speed, that means its velocity is also constant, then acceleration is zero. Acceleration zero means force is zero. And how this force is zero? Because the thrust which is applied by the engine and the resistance which is applied by the wind, that is called wind drag, they are balancing each other. So if the applied thrust, forward force by the engine, and the resisting drag, they are exactly equal, then the total force in the horizontal direction is also zero. and this is because there will be no acceleration, and your aircraft will be keep flying with a constant velocity or constant speed. You can say if it is in the same in one direction. Okay, so this is how at a certain height the aircraft goes at the same height with the same speed because the lift and the weight are balancing each other, and drag and the thrust are balancing each other. Okay. Uh, Although this we do not use in the statics much, but in the dynamics we use a lot, the three quantities which are the vector quantities. First is the displacement, second is the velocity, and third is the acceleration. Okay. So like here, if this is the body at A, okay, it is moving over this path. It is moving over this path, okay, and reaching to this point, which I can call as B. Now, how much distance it has covered? Anyone will tell me?
The
Distance, how much
upper
distance it has?
path, the path.
Yeah, the entire path, okay? The entire path which it has followed, the length of the entire path, that is the distance. And about the displacement, and what will be the displacement?
The shortest distance between 2 points.
Yeah, actually, distance traveled in a straight line. If the 2 points you join by a straight line, like A, you have moved from A and reached to the B. So just you join A and B, okay, by an arrow. So this will be representing the displacement, okay. So even if you suppose you keep moving and then you reach here itself. So A and B are merged at the same point. So how much is the displacement in this case? If you moved all along
The
and
green
then you
path.
reach to the same, yeah, so this will become zero then, because if you are you are sorry, if you are moving along this path and continuing this path and reaching to the same point, so A to B, because they are merged together, so the total if you join them by a straight line, it will have no length, so then the displacement will be zero. So for finding the displacement simply from initial to the final, you join by a straight line. So that will be the magnitude of the displacement. And if you connect by an arrow, so the direction of the arrowhead, that will give you the direction of the displacement. And regarding the velocity, as you know, the speed is a scalar quantity, but velocity is a vector quantity. So what is the velocity? It's basically speed in one particular direction. Okay, it means, for example, if a body is moving over this path, so when you are over here, what is the velocity? That you just draw a tangent. Similarly, when you reach over here, draw a tangent. When you reach over here, draw a tangent. Okay, so these arrows, they are showing the velocity. So this is the velocity of the body at this particular point, and this is the velocity of the body at this particular point. This is the velocity of the body at this particular point. So as you can suppose, if it is on the cruise, then your speed is constant. That means the magnitude you are not changing, but the direction is keep changing. So velocity is keep changing, but the speed is not changing. So speed in a particular direction. So if you are moving in on a zigzag path, if you want to find out the velocity, just draw a tangent. You will know the direction, and magnitude will be the same as speed. So this is velocity. And third is the acceleration, change in velocity in a unit time. So this change in velocity could be because of the direction change or because of the magnitude change. For example, if in a straight line your car is moving and here its speed was 100 kilometers per hour, then after some time its speed has changed to 120 kilometers per hour. Okay, so here the velocity speed has been changed. That means velocity is also changed because velocity speed is the magnitude of velocity. So with change in the velocity, in how much time it has taken, maybe it has taken a very small time like 3 seconds, or let's call it t. Okay, so the change in velocity, that is v2 minus v1 divided by how much time it has taken, that is divided by t. This will give you the acceleration. Okay, and if the speed is constant but direction is changing, that is also an indication of the velocity change in velocity. So is again there will be an acceleration. Okay, like for this problem, here the velocity was in this direction, here the velocity is in this direction. But suppose the car is on cruise, so their magnitudes are constant. So in this case, also you can calculate the change in velocity by even graphical procedure also. Or if you express this, for example, I will come to this like 30i, and this one you can say like minus 20i minus 10j, like this. Then change in velocity, you have to find this minus this. That will give you the change in velocity in the form of vector. And then divide by time, you will get the acceleration. Okay, so acceleration is a vector quantity. Okay, so in the direction in which the change is taking place, that direction will be the direction of the acceleration. Now I am coming to the various operations on vectors. So first we are going to talk about the simplest operation, that is called addition. Addition of two vectors. Here I am going to tell you graphical procedure for this operation. I will also explain to you later analytical procedure. So this is the graphical procedure. In graphical procedure, we represent a vector by an arrow. Like this is an arrow. So the length of the arrow, it indicates what? Length of the arrow. Anybody knows what? In graphical method, you represent a vector by an arrow, and the length of the arrow indicates what?
It's the magnitude.
Magnitude.
Magnitude. Very good. So the magnitude is given by the length, and this arrowhead, this tells the direction. Okay, so this is how we represent the vector in by graphical method. And if you have to add two vectors in order to get the resultant, then you have two graphical methods. First is called law of parallelogram, and other is called law of triangle or triangle law. So suppose this is the vector A and this is vector B, and you want to add them graphically with the help of parallelogram. So whenever you have to add the two vectors graphically by the law of parallelogram, so simply you have to represent the two vectors by the two sides of a parallelogram. So you see, I hope you know what is the shape of parallelogram. You see this type of shape in which the opposite sides are parallel and equal. We call them parallelogram. So here this side, here this side is same as this side, equal to this side. So they are parallel as well as equal in magnitude. Similarly, this side and this side, they are parallel and equal in magnitude. So this shape is called parallelogram. So when you have to add the two vectors, these two vectors you will represent by the two sides of a parallelogram, and then the resultant will be the diagonal. So if I represent this, so this is your vector A and this is your vector B. Now complete the parallelogram, draw a line parallel to this and draw a line parallel to this. Then the diagonal, sorry, I could not make it properly. This diagonal, this will represent the summation of vector A and vector B. Okay. So as you can see here, this is vector A and this is vector B, which we are representing by the two sides of a parallelogram. So you draw a line parallel, sorry, you draw a line parallel to this here and draw a line parallel to this over here. Then connect the diagonal. This diagonal will represent the vector R or resultant, and this will be equals to vector A plus vector B. So this is the first graphical method for finding the addition of two vectors. Another one is the triangle procedure, triangle law. In triangle law, we add the vectors by head to tail. It means at the head of one, you will put the tail of the another vector. So head means this one. These are the heads of the vectors, and tail means this. This is the tail of the vector. Okay. So
Okay,
in triangle law,
Doctor, I
yes,
want to
please.
ask you
Yes, yes.
if you want this is for displacement, right?
No, no. This is for simple any vector A or and vector B. We are not talking about the displacement because displacement is primarily in the dynamics. In statics, we will come to mainly forces. All our vectors will be forces or moments, not the velocity, acceleration, or displacement.
Okay, thank you, Doctor.
Okay, okay. So this is the means head and this is the tail. So when we want to add the two vectors by triangular procedure, triangle law, so like first I can put vector B, and then at the head of the vector B, we can put the tail of vector A. And then join the tail of the first to the head of the last. That will give you the resultant, that is equals to vector A plus vector B. So because this is forming a triangle, we are calling it as a triangle law. So in triangle law, at the head of the first vector, you can take any vector A or vector B, no problem. Like here in this uh, lecture, I am showing vector A as the first vector. So at the head of the vector A, I am putting the tail of vector B. Okay, and then I am joining the tail of the first to the head of the last. So this is the vector A plus B. And this one and this one, they will be 100% same by direction as well as by magnitude. So whether you do it by triangle law or by parallelogram law, both are going to give you the same answer. Okay. So this is the later there is an extension of the triangle law which we call law of polygon. Law of polygon. In law of polygon, you can get the resultant of several vectors. What you will be doing, for example, if you have vector A, vector B, vector C, vector D, like this, and you want to add them. So it is head to tail. So you can start from, say, vector A. So this is your vector A. And at the head of vector A, you can put the tail of vector B. And at the head of the vector B, you will put the tail of vector C. And at the head of vector C, you will put the tail of vector D. And then you will draw a vector from the tail of the first to the head of the last. So that is this one. And this, if I call as vector R, so this vector R will be equals to vector A plus vector B plus vector C plus vector, C plus vector D. Vector A plus vector B plus vector C plus vector D. So this is called law of polygon. So it is a simple extension of the triangle law. As far as the parallelogram law is concerned, there is no extension of the parallelogram. Parallelogram law will consider only two forces or two vectors at one time. Okay. So if you have several vectors acting on the body, and you want to use the law of parallelogram, then in that case you will require to take the resultant of two at one time, and then this resultant you take with third. So what we are doing, just you move this for our vector, say over here, and move this over here. And you will get this as vector R. Now, because this and this you have considered, vector A and vector B have considered, but vector C is still there. So what you will do, then you can extend this, sorry, oh, it is gone. So, 1 minute. So we had this resultant, and there is also a force here. So after getting this resultant, this is the line of action, and this is the line of action. So you move this force over here, and move this over here, and then draw a line parallel to this, draw a line parallel, and then this will be the result. So what you are seeing here, that in parallelogram law, at one time only two forces you can consider, After getting the resultant of the two forces or two vectors, you will get the you will take the resultant of the first resultant with the third one. So you will get the final resultant like that. So if you have the number of forces, it is very time consuming graphically by parallelogram law. But by the extension of the triangle law, that is a law of polygon, it is in one shot you can get the result. But it doesn't mean that parallelogram law is uh, is inferior. Actually, the advantage of parallelogram law is that the line of action of all the forces, they are maintained. But in the triangle law or extension of the triangle law, this may not be maintained. What I mean to say that if suppose you have the one force here, it's difficult to make the drawings on this. You have one force here acting on this body and another force is acting here on this body. So this is the line of action of this vector and this is the line of action of this vector. So you move them along their line and then complete the parallelogram, you will get the result. So here line of action of the two forces are maintained, they are not changed. Okay, but if you want to do this by triangle law, so in this case you have to move this force from here to here, or 1 minute, if you take this this way, so either you will see, if you again the same problem will occur here. This is one force and this is the another force. So this is the line of action of this force and this is the line of action of this force. So if you want to do this by triangle law, so you can move this over here. Then this force you cannot put it here. You have to move it to the head of this in order to add them. Okay, and then you will get the result. So what you are seeing, the line of action of this force was this one, or this vector was this one, which you have changed to here. So line of action of the vectors, they may not be maintained in case of triangle, although you will get the same answer, because when we say the two vectors are in the same direction, that means they are parallel. So you will get the same answer as the parallelogram, but the line of action will not be maintained of the vectors. So this is the one of the disadvantages of the triangle law, and the major advantage of the parallelogram law is that line of action of all the forces or all the vectors, that will always maintain. Then we come to the subtraction of two vectors. As far as the subtraction is concerned, the subtraction is a special case of addition. So what you do actually in subtraction, just suppose you want to subtract A from B. So just reverse this direction. So this is the vector A. You reverse this to like this. So this will become minus vector A. Then you can use the parallelogram addition law or triangle law in the same way. So like here, the two are showing this is vector B and this vector minus vector A. Now you can represent these two by the two sides of a parallelogram. So the diagonal will represent the resultant. That is vector b plus minus vector A, that is vector minus vector A. Same thing here, head to tail. At the head of the minus vector, you put the tail of the vector b, and then join the tail of the first to the head of the last. That is the resultant. Okay. So what you have seen, that subtraction is a special case of addition in which just the quantity which you have to subtract, eh, that you reverse its direction. So invert its direction, so it will become negative, and then you add as we added before. Okay. All right. So I am closing today here.